Hello everybody, my name is Ananya Kantraj. So today I'm here with another video of the topic bisection method and Lagrange's interpolation method. So let us look forward. So what are the contents of bisection method? First, second bisection method definition, third bisection method algorithm, fourth bisection method example, and fifth Lagrange's interpolation formula. So, what is bisection method? In mathematics, the bisection method is a straightforward technique to find numerical solutions of an equation with one unknown. Among all the numerical methods, the bisection method is the simplest one to solve the transcendental equation. In this article, we shall discuss the bisection method with the solved problems in detail. So what is bisection method definition? So let us look into the basic definition of the bisection method. The bisection method is used to find the roots of a polynomial equation. It separates the interval and subdivides the interval in which the root of the equation lies. The principle behind this method is the intermediate theorem for continuous functions. It works by narrowing the gap between the positive and negative intervals until it closes in on the correct answer. This method narrows the intervals. It is a simple method and it is relatively slow. So the bisection method is also known as an interval halving method, root finding method, binary search method, or dichotomy method. So let us consider a continuous function f, which is defined on the closed interval a comma b, is given with f of a and f of b of different signs. Then, by intermediate theorem, there exists a point x belong to a comma b for which f of x is equal to 0. So, bisection method algorithm. So, follow the below procedure to get the solution for the continuous function. So let us look into the bisection method algorithm to find the solution for the given problem. So first, for any two continuous function f of x, find 2 points, say a and b, such that a is less than b and f of a into f of b is less than 0. Third point, find the midpoint of a comma b, say p. That is nothing but a and b. So, fourth point is that t is the root of the given function if f of t is equals to 0, else follow the next step. Fifth point, divide the interval a comma b, which is the closed interval. If f of t into f of a is less than 0, there exists a root between t and a. Else, if f of t into f of b is less than 0, there exists a root a between t and b. So repeat the 3 steps until f of t is equal to 0. Now, the bisection method is an approximation method to find the roots of the given equation by repeatedly dividing the interval. This method will divide the interval until the resulting interval is found, which is extremely small. So let us look into an example. I have taken a simple problem here, which states, according to the question, that determine the root of the given equation, x square minus 3 is equal to 0, for x belongs to the closed interval 1, 2. So let us look into the solution. It is given that x square minus 3 is equal to 0. Let f of x is equal to x square minus 3. Now, find the value of f of x at a is equal to 1 and b is equal to 2. F of x is equal to 2 by substituting the value of the equation x square minus 3 is equal to 0. We will substitute x as 1. We'll get 1 square minus 3, which is nothing but 1 minus 3, which is equal to minus 2, which is quite less than 0. Second, f of x is equal to 2. So let us substitute f x equal to 2 in the equation x square minus 3 is equal to 0. We will get 2 square minus 3 is equal to 2 square is nothing but 4 minus 3, which is nothing but 1. It is greater than 0. Hence, the given function is continuous and the root lies in the interval of the closed interval 1, 2. Let t be the midpoint of the interval as mentioned in the algorithm. That is, t is equal to 1 plus 2 divided by 2. which is equal to 3 by 2, which is nothing but 1.5. Therefore, the value of the function at t is f of t is equal to f of 1.5, which we obtained in the above step, which is equal to, substitute the above value of f of t in the first equation, which is nothing but x square minus 3 is equals to 0. We are going to get the value as 1.5 the whole square minus 3, which is nothing but 2.25 minus 3, which is equal to minus 0.75, which is quite less than 0. If, as mentioned above, f of t is less than 0, assume a is equals to t. And if f of t is greater than 0, assume b is equals to t. Now, f of t is negative, so a is replaced with t, which is equal to 1.5 for the next iterations. So the iterations of the given function are as follows. So by substituting for f of a and f of b, we have obtained the above iterations. So at the 7th iteration, we get the final interval as 1.7266, 1.7344. Hence, 1.7344 is the approximated solution for the given above question. Let's move on to the next topic, which is nothing but Lagrange's interpolation formula. So, Lagrange polynomials are used for polynomial interpolation. For a given set of distinct points and numbers, Lagrange's interpolation is also a degree polynomial, approximation to f of x. So, we can find the Lagrange's interpolation formula as given below, which states that y is equals to x minus x1 into x minus x2, so on up to x minus xn, divided by x0 minus x1, x0 minus x2, x0 minus xn into y0 plus x minus x0, x into x minus x2, so on up to x minus xn, divided by x1 minus x0 into x1 minus x2, so on up to x1 minus xn into y1, plus till the nth value, that is nothing but x minus x1 into x minus x1, so on up to x minus xn minus 1, divided by xn minus x0 into x0 minus x1, so on up to xn minus xn minus 1 into yn. So, what exactly is Lagrange's interpolation formula? It's nothing but it finds a polynomial called Lagrange polynomial that takes on certain values at an arbitrary point. It is an nth degree polynomial expression to the function f of x. The interpolation method is used to find the new data points within the range of the discrete set of known data points. So let us look into a solved example. So the question states that find the value of y at x is equals to 0, given some set of values minus 2, 5, open interval 1, 7, 3, 11, 7, 34. So what is the above solution for this question? So given that the known values are x is equal to 0, x0 is equal to minus 2, x1 is equals to 1, x2 is equals to 3, x3 is equals to 7, and y0 is equals to 5, y1 is equals to 7, y2 is equals to 11, and y3 is equals to 34. So now, let us apply the Lagrange's interpolation formula, which is nothing but y is equal to x minus x1 into x minus x2, so on up to x minus xn, divided by x0 minus x1 into x0 minus x2, so on up to x0 minus xn into y0, plus x minus x0 into into x1 minus x2, so on up to x minus xn, divided by x1 minus x0 into x1 minus x2, so on up to x1 minus xn into y1, plus so on up to the nth term, that is nothing but x minus x1 into x minus x1 into so on up to x minus xn minus 1 divided by xn minus x0 into x0 minus xn into so on up to xn minus 1. So, into yn. Hence, by substituting the values, y is equals to 0 minus 1 into 0 minus 3 into 0 minus 7 divided by 2 minus 1 into 2 minus 3 into 2 minus 7 into 5, which is nothing but y1, plus 0 minus 2 into 0 minus 3 into 0 minus 7 divided by 1 minus 2 into 1 minus 3 into 1 minus 7 into 7, which is nothing but y2, plus 0 minus 2 into 0 minus 7 into 0 minus 7 divided by 3 plus 1 into 3 minus 1 into 3 minus 7 into 11, which is nothing but the y3. So it is 3 minus 2. Next, the last step, which is nothing but 0 minus 2 into 0 minus 1 into 0 minus 3 divided by 7 minus 2 into 7 minus 1 into 7 minus 3 into 34, which is nothing but y3. Hence, we have only three terms, that is y1, y2, and y3, and substituted in the above values. So on simplification, we're going to get the answer as 21 by 27 plus 49 by 6 plus 77 by 20 plus 51 by 4, which is nothing but 1087 divided by 180, which is the final answer. So thank you for watching my video. Please do like, share, and subscribe. Thank you one and all.